Okay, starting chapter 7, confidence intervals. We're going to do population proportion. We're going to find a sample proportion, which is p hat. Oops. So that's from the sample. And we learned before that it targets the parameter that's the population proportion. So this is the statistic that targets the parameter. Now there's a lot in this PowerPoint slide, not a lot of it's redundant. So I'm gonna blow through a lot of slides. You got time to read them and read the book. Okay, here's the problem that we're gonna do. And so I'm just gonna give an idea of the nutshell here, what the whole purpose of this confidence interval stuff is. So we take our sample and 43% said they had a Facebook page. So p hat is 0.43. And the way that was found was in this survey, 639 people said they had a Facebook page over our total. The 639 you may read is X, and then of course that sample size, which is N. Yeah, we've done all this. P hat and P. Okay, so what are we trying to do? What we're trying to do is get some kind of interval. So we're going to have a value for p hat. In this case, it's 0.43. Well, we're going to go out so far this way by adding something, and then we're going to go out so far this way by subtracting something. And that thing that we are adding and subtracting is called the margin of error. That's this distance in between there and here. So really what this is all going to boil down to is, how do we find the margin of error? How do we add it to p hat so that now we have this interval where we have some kind of confidence that the true value of p lies in here. We can never be perfect because it's statistics. We're just gathering some evidence. There we go. We're finding a CI, a confidence interval. Okay, we're actually going to do a 95% confidence interval. So this goes back to our old normal distribution, where this alpha is 5%, but we're cutting into these tails. So in between here is our 95%. Out here is half of alpha, in this case 0.025. And so that's alpha over 2, and the same thing over here. Here's some alphas that correspond. There's just one subtract. Alpha is the confidence interval. It's a complement, right? Okay, this slide is way too advanced, or it comes up too fast. Basically, we got to figure out how to find that. I'll worry about that at the end. You can read that. You can read that. This basically shows that not all the confidence intervals that we could make would capture P. We're just going to say that we're 95% confident that the true value of P lies in our interval. That's all we can say. Okay, these critical scores. I'm just going to do it right here and find the one for what we're doing. We've done this. Notice how we're building on all the stuff from chapter 6. So this is alpha over 2. For us, it's 0.025. So we need this area to the left of my critical z-score, my z alpha over 2. Well, we know there's 0.95 from our confidence interval, but that only goes out to here. Don't forget there's another 0.025 in here. So the total area to the left is 0.9750. And if you look into your positive z-scores, you will see that the z-score is 1.96, which has this area to the left. So in this case, our critical z, which I may say is z with a c, is 1.96. With confidence intervals, there's usually 3 of them. They're at the bottom of that positive z-score thing. So now we've got our critical z-score. We just did that. Now that we've got it, I'm going to show you how we use it. Remember that little margin of error thing I was talking about? It's z alpha over 2 times the square root of p hat q hat divided by n. So we're going to find this, and then all we're going to do is we're going to subtract it from p hat. We're going to say that's less than the parameter p, which is less than our p hat plus the margin of error. So really, these are the 3 steps. Decide what the confidence interval is. We're at 95%. Find the critical z. Plug it in here. Notice that's all from your data. So if I want to calculate this, and this is probably just as good a place as anything. Let me erase some stuff. Let's put in our values and I'll find our E. 1.96 square root of p hat was I forgot what p hat was, 0.43. Q hat then is 0.57, the complement, and our n is 1487. Let's find that. So you got to learn your calculator. We're getting into some really strange formulas here. We're going to take a square root. I got 0.025, and the book doesn't round here, but I round about there because we're in the 10,000ths place. Let me erase this. And now I'm going to finish my confidence interval. P hat 0.43 subtract 0.0252 is less than P is less than, I can't believe I don't have enough room here. Then add it. .405 is less than P, it's less than 0.555. So if we're going to finish, what I would say, we now have some evidence. We're 95% confident the true value of P lies in this interval. So if you wanted, you could talk about percentages, of course. You could say true value of P looks like between 40.5% of people have Facebook, and that's between 45.5%. So essentially, that's what this whole section is about, except for a little bit of other stuff. That's finding a confidence interval. Did all that. There we go. Like I said, this is at the bottom of your positive Z-score chart. Doesn't take long until you end up memorizing those. We talked about margin of error. There it is. We just did it. Now, I didn't do this beforehand, but we'll start to do this now. Simple random sample. The binomial distribution, that's usually with proportions because it's either do you have Facebook or do you not, so it's yes or no. And this hardly ever comes into play because usually the sample sizes are large enough, we don't worry about that. There it is. Everything in one place. The whole idea is the CI, like if I said 90% confidence interval, then my Z alpha over 2 would be 1.645. That's here, all that's from the data. You go back to your P hat that you got from your problem or from your data, calculate E, subtract and add it. And I'm just wondering if there's anything, here we go. This is the thing. This is what we're gonna do. Suppose there was a claim, and I need some white space. Give me my, here we go. So suppose someone had a claim. 50% of people have Facebook. It's probably lower than that. We now have evidence right here because we're saying this. We're 95% confident the true value of P lies in this interval. Therefore, we're going to reject the claim. We don't say it's wrong. We just reject it because now we have evidence that says we think it's wrong. Because we're 95% confident that the true value of P lies in our confidence interval. In the next video, I'll do a few practice problems just to show you how quickly you can do this technique. And then I'll look at, suppose we want to be within a certain margin of error, what would our sample size have to be? Stop that too.